fourth graders, it's Mrs. Compton, and today we are going to look at finding factors and multiples and using arrays to really help us understand what those things mean. So we've got a story problem and arrays coming at you today, and we're going to check this out. Toy animals are sold in sets of 3, 5, 10, and 12. All right, so imagine going to the store and finding a set of animals in 3, and then you could buy them in groups of 5 or groups of 10 and 12. So Mason wants to make a display with 3 animals in each row. Which sets could he buy if he wants to display all of the animals? Okay, so we could think about factors first, or multiples, but let's try out factors first. All right, so I'm really going to be thinking about, is 3 a factor of those numbers? So let's check it out. I think I'm actually going to make myself a little list over here. So I have 3, 5, 10, and 12. And I'm just going to write yes or no beside each one of those so I can keep track. Okay, so he wants to make sure to put 3 animals in each row. So will that work out if he buys the pack of 3 animals? Let's find out. You already knew that would work, right? So of course he could make a display with 3 animals in one row. So that would be a yes. 3 is a factor of 3. Now we're going to try to find out, is 3 a factor of 5? Now, if we have the number 5, can we make rows of 3 without gaps or overlaps? So there's one row of 3 and a second row, but it doesn't make 3. So that means that 3 is not a factor of 5. So this one is a NO. All right, let's move on to 10. Ah! My tower is going to fall over here. There we go. I'll just knock it over so that it doesn't have to explode onto the floor. Okay, so I still am putting 3 animals in a row, but this time my number is 10. 1, 2, 3. All right, now I have to start a new row. Some of you probably already thinking you know the answer because you know the answer to a multiplication equation. Maybe you're thinking about 3 times 3 is 9. So that means 10 cannot be a factor because we would need 2 more. So, or actually I should have said 3 is not a factor of 10. You can't arrange them into a perfect array. So that is a no-go. All right, let me move these guys up so that we have room for the 12 coming at us. So that was it. This one, this one, this one. All right, so here comes 12. Do you think I'll have space? I don't know if I'm going to have space. We're going to find out. All right, so I still have to put these in rows of 3, but now I have 12. 1, 2, 3. 1, 2, 3. I've used up 6. Ah. I've used up 9. See if I can squeak that last one in there. 10, 11, 12. Yeah, there we go. I made it work. Okay, so that is a yes because we were able to make a, let's see, we have a 4 by 3 array, right? So that is a yes. No gaps or overlaps right there. Okay, now, the other way we could have thought about it is by counting by multiples. Oftentimes, people confuse factors and multiples. Factors are, you can multiply numbers together to make a product. For example, 3 times 6 is 18. 18 is the product, 3 and 6 are the factors. Multiples are what you say when you count by a number. You've been learning multiples since like 2nd grade, or actually 1st grade when you go 10, 20, 30, 40, 50. Those are multiples of 10. All right, so you could have also checked to see if each of these things were a multiple of 3 by counting by 3. So if it shows up on the list, then it's a multiple of 3. So here we go. We're going to count by threes. 3, 6, 9, 12. All right. 3 showed up. That's a yes. 6 is on our list, but we skipped 5. So we weren't even worried about that number. And we're also not worried about that number. But that means 5 would have gone here. So that's 5's a no. And 10 would have gone here. And so that's a no. It didn't show up on our list when we were counting. And then 12 did. So that's a yes. So we can think about things as factors or multiples. It just depends on how you want to approach your thinking. All right, kids, I'll see you next time. Bye.